Okay, we'll pick up where we left off last time, and it was here. The force of kinetic friction, and there's a little subscript F, and we can even put a little subscript K there to indicate that it's the force of kinetic friction, is mu K times Fn. Okay, and because there's nothing else happening in the vertical direction, we know that the Fn is actually equal to mg. We've got the down forces are mg. That's the force of gravity acting down. And maybe I'll draw that free body diagram over here again. So there's your mass. There's your uh, force applied. There's your force of friction. There's your force of gravity, which is mg. And here's your normal force, which in this case is also equal to mg. And the force of friction here is equal to mu k times Fn, which is mu k times mg. So there's a lot of stuff going on here, but there you go. And now let's put in that F net statement again. The F net is equal to your applied force minus the force of friction, right? Because it's happening here in the horizontal direction only. And in this case, our F net is 0. So we can put in 0 for our F net. Our F applied is 94 newtons, and our force of friction is mu k times 50 times 9.81. So I've got my M, I've got my G, my mu k I don't know. But in this case, I have the same amount of pushing force as I have friction force. So I can do this. I know that my mu k in this instance is going to equal 94 all over 50 times 9.81. And now I can find out what the coefficient of kinetic friction is. And it's 0.19. 0.19. Now, there are no units for the coefficient of friction. So there's no units to it. And what it is, if you look at the equation back here again, so the force of friction is equal to mu k times Fn. This is a decimal. It's actually a percentage. So it's a percentage of how strong the force of friction is compared to the normal force. So what this is telling me is that in this particular scenario, the force of friction is going to be 19% as strong as the normal force. And if I were to put more mass on top, the force of friction would increase. It would still be 19%. It would still be 0.19. But because the normal force has now increased, my force of friction has gone up. And we can do all kinds of problems like this. So that's what we're dealing with. And if I move this bar here, that's going to increase this percentage, and it'll go up to, I think lots means it would be around like 100%, and none would be 0. So this range you have here is 0% the normal force, 100% of the normal force, and here in the center, I guess, I don't know, we're at 0.19. Maybe I'm wrong. Maybe that's only like 0.38. But that's what it is. People always ask me, like, what are the units for your coefficient of friction? There are no units. It is a percentage comparison. So you would have this, the force of friction in this particular, and it's going to be kinetic friction, is 0.19 times Fn. And so how I would read this is, the force of friction is 19% as strong as whatever the normal force is. And we could decrease the normal force by kind of lifting the box a little bit, or we could increase the normal force by putting more pressure on top of the box. But the force of friction will always be 19% of whatever that whatever the normal force is between the box and the surface here.